The universe is vast beyond comprehension, but sometimes it sends us something that cuts through the cosmic silence like a siren in the dark. For decades, Voyager 1 has been drifting quietly, a lonely messenger far beyond the boundary of our solar system, surrounded by emptiness so absolute it's like floating between the echoes of creation itself. Then, out of nowhere, our aging spacecraft detected something scientists never anticipated. A persistent signal, faint but undeniable, emanating from the depths where no telescope or probe has ever visited. The initial data didn't just raise eyebrows, it triggered urgent conversations behind closed doors at NASA and observatories around the world. Every expectation we held about the nature of interstellar space was suddenly in question. Was this the background hum of the galaxy? A cosmic storm? Or something we don't even have words for yet? What Voyager found did not fit any model, any theory, or any imagination. It has been described as impossible, baffling, and astonishing all at once. And right now, almost no one outside a select group of scientists even knows this signal exists. What secret is hidden out there, just beyond the reach of all earthly knowledge? Tonight, you'll hear the full story. Stay with me, because in the next few minutes, you'll discover not just a new chapter in Voyager's journey, but a riddle that might transform our understanding of the universe itself. On September 5th, 1977, a slender rocket pierced the Florida sky, carrying with it a payload whose significance wouldn't fully be understood for decades to come. Voyager 1 was launched not with dreams of interstellar fame, but with a practical mission. Capture detailed images of Jupiter and Saturn, relay fresh scientific data, and then quietly fade from memory. Its systems were finite, its expected lifespan only 4 or 5 years. At the time, no one imagined this small spacecraft, built when color television was considered high-tech, would one day hold the title of the farthest human-made object from Earth. Those first years went according to plan. Voyager 1 sailed past Jupiter in 1979, revealing intricacies of the Great Red Spot and volcanic activity on Io with clarity never before witnessed. In 1980, it skimmed by Saturn and sent back hauntingly beautiful images of its rings and enigmatic moons. Then, propelled by the gravitational slingshot of these giant planets, Voyager didn't just keep going. It defied every prediction. Year after year, decade after decade, as equipment and programs at NASA cycled in and out of relevance, Voyager's faint beacon continued its transmission. Technicians marveled as it survived cosmic radiation, sub-zero darkness, and distance itself, living on borrowed time and ingenuity. Over the years, Voyager 1 crossed a series of invisible boundaries, each marking humanity's collective reach further into an unexplored sea. In 1990, before turning its cameras off, it captured the pale blue dot portrait, Earth as a speck in the vastness, reminding us how small and fragile our world is. By 2012, the spacecraft passed through the heliopause, officially leaving our solar neighborhood and entering true interstellar space. Its instruments, running on less power than a common light bulb, continued to relay whispers from realms where no human or machine had ever dared venture. Today, Voyager 1 is more than just a probe. It is an unlikely survivor, the embodiment of curiosity and audacity. A 4-decade-old machine threading a lonely path between the stars, guided only by the hopes and questions carried from Earth so long ago. What it has now found was never in its mission plan, but its journey is rewriting the story of what's possible. Before Voyager 1 ventured into the unknown, the scientific community had painted a very different picture of interstellar space. The prevailing model described it as a vast, quiet void. A cosmic desert where particles drifted lazily in near-perfect uniformity, like dust settling in an abandoned library. This was the space between stars, a region so sparse and still that astronomers compared it to the calm before a storm that never comes. The heliopause, the boundary between our solar system and interstellar space, was expected to be a gentle gradient, where the sun's influence simply faded away like the last notes of a symphony. Models predicted a smooth transition, with the solar wind petering out as it met the interstellar medium, creating a serene, almost featureless expanse. The plasma between stars was thought to be thin, cold, and remarkably stable. A cosmic waiting room where not much happened. Scientists had built these models from Earth-based observations and theoretical calculations, confident that the space beyond our solar bubble would be as quiet as the night sky appears to our eyes. Even the magnetic fields were expected to maintain a clean separation, with our sun's domain ending abruptly at the boundary, giving way to the galaxy's own magnetic personality. This was the universe we thought we understood, predictable, ordered, and fundamentally calm. Temperatures were expected to be consistent, particle densities uniform, and the entire region a textbook example of cosmic equilibrium. The heliosphere's edge was imagined as a simple membrane, not a dynamic frontier. Every telescope and every calculation pointed to the same conclusion. Interstellar space was the ultimate in cosmic monotony. The theories were elegant, the math was sound, and the consensus was absolute. After all, how could a region so far removed from any star possibly sustain activity or complexity? It was the perfect picture of cosmic stillness, A. Silent expanse waiting to be confirmed by the first probe brave enough to reach it. But when Voyager 1 finally crossed the heliopause and began transmitting data from the other side, what it found shattered every expectation. The probe's plasma wave instrument, an unassuming sensor designed in the 1970s, began to pick up a persistent, narrow-band emission from the interstellar environment. This was not a random blip or a familiar burst of static. It was a continuous, low, humming signal that had never been seen before. For years, Voyager recorded this strange phenomenon, each transmission delivering more of what scientists couldn't quite comprehend. It wasn't a single event or a brief anomaly, but a steady background song stretching across nearly 1 billion miles of empty space. Initial attempts to explain the data fell short. This hum didn't match any known cosmic process or predicted model. It was too constant to be a passing shockwave in two, organized to be dismissed as noise. Peer-reviewed papers poured in as experts scoured every detail, hoping to find clues in the magnetic field measurements or plasma density variations. Instead, every data point deepened the enigma. Instead of a placid, uniform void, interstellar space appeared alive with fluctuations. Turbulent, structured, and unpredictable at every scale. The revelations triggered an intellectual panic in some of the world's top astrophysics labs. If the vast gulfs between stars were not calm but crackling with unanticipated energy, what else might lurk beyond our models? The intensity of the signal was baffling. It had traveled undisturbed over impossible distances, outlasting cosmic storms and solar events, remaining surprisingly stable. The mathematics that had long underpinned our understanding of the galaxy suddenly seemed too simple. For the first time, scientists admitted the possibility that the environment beyond our sun's protective bubble is far more complex, and possibly hazardous, than anyone had dared to guess. NASA's Jet Propulsion Laboratory went into overdrive, spinning up emergency collaborations around the world. What if this anomaly was only the leading edge of something bigger? Could it be evidence of vast structures or cosmic weather systems unknown to science? The headlines, rarely so breathless about deep space missions, dared to use words like astonishing, impossible, and even panic. Still, the most uncomfortable truth persisted. Despite global attention and the best minds in astrophysics, no one could yet give an answer. The signal kept coming, indifferent to our confusion. Out there, between the stars, the rules were different. And what Voyager had uncovered still refuses to be explained, even as it invites us to question everything we thought we knew about the boundaries of our universe. As the data mounted, theories piled up nearly as fast as they were dismissed. Some. Researchers initially proposed that Voyager's signal was interference, a technical artifact from an aging spacecraft nearly half a century old. Maybe cosmic rays had scrambled its sensors, or perhaps the hum was just electronic background noise amplified by the emptiness of interstellar space. Yet, careful checks and cross-referencing against other instruments proved these ideas were wishful thinking. The signal's unique properties persisted, baffling engineers and physicists alike. Other teams speculated this could be a kind of plasma oscillation, an effect of charged particles vibrating in the unique environment between stars. But the pattern was strangely stable and consistent, unlike any natural plasma wave previously modeled or detected in laboratory conditions back on Earth. The signal's frequency didn't shift with solar activity or Voyager's changing position, further deepening the puzzle. A few even wondered if Voyager had stumbled onto a new kind of interstellar weather, or unknowingly passed through an unseen structure, like a vast, slow-moving filament of energy threading its way across the galaxy. Conferences and late-night video calls between scientists from around the world became routine as major institutions scrambled to collaborate. One NASA project manager, his voice thick with awe in a rare public interview, admitted, "It's the ultimate reminder that space doesn't care about our predictions. It's humbling and thrilling, all at once." A plasma physicist from Harvard put it more starkly, "Frankly, we just don't know. And that's the most exciting part." The uncertainty carried a strange emotional weight. For every theory that failed, the sense of anticipation and collective wonder only intensified. Was Voyager picking up the faint pulse of a gigantic shockwave from a supernova long vanished, or surfing the whisper of an ancient cosmic collision? Or had we simply missed something fundamental in our models, forcing a rewrite of how we understand every corner of the galaxy? Each new data packet acted as a fresh riddle, taunting humanity's best minds. The longer the hum persisted, the more the scientific community and an attentive public leaned in. This was no mere curiosity. It was a signal from the darkness, a cosmic challenge. The next answer could upend everything, but for now, the mystery only grew deeper and more irresistible. But this discovery is not just an abstract puzzle for astrophysicists to debate in quiet university halls. The turbulent, energetic reality of interstellar space that Voyager 1 just revealed reaches back here, directly affecting the survival of life on Earth. For billions of years, our solar system has been wrapped in a protective bubble called the heliosphere. This invisible shield, generated by the solar wind, deflects the most dangerous forms of cosmic radiation, high-energy particles born from the violent deaths of distant stars. Without this shield, that radiation would strip away our atmosphere and bombard the surface, making life as we know it impossible. We always believed this boundary was stable, a reliable fortress wall holding back the chaotic void. But the data suggests the environment pressing against our shield from the outside is far more violent, variable, and energetic than we ever imagined. If the interstellar medium is a raging storm rather than a calm sea, then our protective bubble is being battered by forces our models never accounted for. What happens if that shield weakens? What happens if the magnetic reconnection at the boundary allows dangerous radiation to leak through? The implications for biology on Earth are enormous, a sudden shift in the cosmic weather. Pressing against the heliopause could expose our planet to radiation spikes capable of disrupting global power grids, crippling satellite networks, and drastically altering our climate. It raises a chilling, existential question. How vulnerable are we? Really? We like to think of Earth as a safe haven, isolated from the dangers of deep space. But Voyager 1 is telling us that the wall protecting our home is interacting with a universe far more dynamic and unpredictable than we knew. We are not just observing a distant anomaly, we are looking at the very edge of our own vulnerability. The cosmos is knocking on our door, and we do not yet know if it is a warning or just the first sign of a much larger cosmic storm heading our way right now. Every single new data packet forces us to reconsider our safety. Just as the mystery deepened, Voyager 1 itself faced its own battle for survival. After decades of flawless performance, the spacecraft suddenly began sending back garbled, unreadable signals. Scientists at NASA's Jet Propulsion Laboratory held their breath as they realized the data was no longer making sense. Every screen in the control room blinked with confusion, and the deepest fear set in. Had Voyager reached the final silence at the very moment we needed it most? For 5 agonizing months, all they received was what looked like cosmic gibberish. The team suspected a radiation-damaged memory chip, but locating and correcting the fault from nearly 15 billion miles away was close to impossible. Every single command took 22 hours to reach Voyager, and another 22 for a response to return. The margin for error was razor thin. One wrong instruction, and the signal could vanish forever. Engineers and programmers, many of whom were not even born when Voyager launched, came together from across generations for an unprecedented remote rescue. Through endless patience, sleepless nights, and constant reanalysis, they developed a daring plan: bypass the corrupted memory region, rewrite the probe's operating code, and store the critical software in functioning memory blocks. This was, in essence, digital brain surgery performed across the void. Each new workaround meant risking all communication, yet with quiet heroism, line by line, they rebuilt the pathways for Voyager's messages. Finally, a signal came through, clear, sharp, and unmistakably real. Voyager had awakened from the edge of its final sleep. The mission's recovery was celebrated in hushed astonishment. Those who saw it described it as saving a friend from the brink of death. The journey that had seemed doomed was once again transmitting clues from deep space. Yet this crisis underscored a chilling truth. Voyager's survival is fragile, and the universe is not patient. With each passing year, the threat of permanent silence grows closer. For now, heroic ingenuity kept the door open just long enough for the next data, the next revelation. But what if next time, luck runs out? Stay with me, because what comes next could be Voyager's last message. Voyager 1's revelations have triggered a scientific arms race unlike anything in recent memory. Inside NASA's strategy rooms, urgency has replaced curiosity. The reality is sobering. Voyager's aging systems won't last forever, and every transmission could be its last. Each packet of data it sends, every strange hum, every glimpse beyond the heliopause represents an unrepeatable window into the unknown. Scientists know all too well that once Voyager goes silent, our only live outpost in interstellar space will vanish. and the next opportunity could be decades away. In response, space agencies across the globe are accelerating plans to build the next generation of deep space explorers. NASA's interstellar probe concept, once a distant hope, is now a priority. Its goal: to launch a cutting-edge spacecraft capable of reaching and surviving the interstellar medium, equipped with modern instruments engineered to answer the riddles Voyager revealed. The plan is bold: deploy new plasma analyzers, quantum magnetometers, and sensors that can capture far more detail and complexity than Voyager's vintage tools ever could. But designing, funding, and launching such a craft is a marathon, not a sprint. Even if built tomorrow, it would take decades to cross the solar system's boundary. Other agencies are joining the race. The European Space Agency and Japan have initiated joint studies for interstellar missions, seeking international cooperation to share the astronomical costs and scientific returns. Even private companies and visionary engineers are proposing faster, smaller scouts, leveraging breakthroughs in solar sail propulsion, miniaturized technology, and AI-driven navigation. Everyone agrees, time is. Not on our side. Meanwhile, ground-based radio telescopes and Earth-orbiting observatories are scouring the cosmos for similar signals, hoping to triangulate Voyager's discovery or find echoes of the same anomaly elsewhere. But nothing matches the value of a probe transmitting directly from the heart of the void. Every new research initiative, every funding discussion, circles back to the same point. Voyager's clock is ticking, and our window to study untouched interstellar space could slam shut at any moment. That sense of urgency isn't just about knowledge. It's the thrill and the fear of standing on the brink of a new era, knowing we might lose our only messenger before the next generation is ready. The science race is on, and humanity will have to move faster than ever to keep its place at the edge of the unknown. For all that Voyager 1 has shown us, its most significant legacy may be the questions it leaves behind. The signal still defies every tidy explanation. Are we detecting a new kind of plasma phenomenon, or is it evidence of structures, filaments, waves, or boundaries? In the interstellar medium we never imagined existed? Is this hum a feature of deep space everywhere? Or is Voyager simply passing through one extraordinary patch of the galaxy, a coincidence timed perfectly with humanity's first messenger? Some theorists have even begun to wonder if we're glimpsing effects of unknown particles, faint echoes of cosmic events so old and vast that no telescope on Earth could catch them. Is it possible that the rules of physics themselves shift ever so slightly beyond the sun's protective shield? As Voyager's signal grows fainter and its instruments begin to fail, the race to interpret its cryptic messages is more urgent than ever. Will our next probe arrive soon enough to confirm or refute these findings, or will we be left with decades of speculation and unsolved mystery? What if this is our only chance in a generation to look behind the curtain separating us from the rest of the galaxy? The truth is, even the most brilliant scientists can only guess at what's truly happening out there. In many ways, Voyager's journey leaves us with more uncertainty than we started with. An exhilarating, unsettling sense that the universe is still hiding secrets just out of reach. And that's where you come in. What do you believe is happening in interstellar space? Could the answers rewrite our textbooks? Or is there something even more surprising yet to be discovered? Drop your theories and questions in the comments. Your ideas might shape where the next chapter in this story goes. The story isn't finished yet, and the next breakthrough could come from anyone willing to keep searching. As Voyager 1 sails deeper into the dark, its faint signal becomes a fragile bridge between humanity and the unknown. This small spacecraft, built with the technology of a distant era, has become more than metal and circuitry. It is a testament to human curiosity, a glowing ember of exploration shining through a universe that often feels indifferent or even hostile to our dreams. Against impossible odds, Voyager has endured, carrying our questions, our music, and our hopes farther than anything else we have made. The discoveries Voyager has made are not just for scientists or engineers. They belong to all of us, reminders that even in an age overwhelmed by information, real wonder still lies in things we have not yet explained. Each mysterious signal is a call to listen more closely to the cosmos and, by extension, to each other. The more we learn, the more we realize how much we have yet to discover. Our story as a species is not just about answers, but about the courage to keep asking questions, even when the universe refuses to yield them easily. So don't let the signal fade unnoticed. Share what moved you in Voyager's tale, subscribe to stay part of the search, and invite others who crave real mysteries. As long as we keep listening, Voyager's journey, and our own, are not over. The next revelation could change everything we know about our place in the universe.